8051 instructions are broadly classified into five functional groups. Arithmetic group of instructions, logical group of instructions, data transfer operations, Boolean variable operations, program branching operations. Let us see one by one in detail. Arithmetic group of instructions, and before we start with any instruction format, every operations in 8051 will be normally communicated through accumulator. So the basic structure of any instructions will be having mnemonics followed by an operand, then we will have a destination, and then we will have a source. So when we say mnemonics, it's normally a keyword, and followed by we have an operand, that is variables, and then we will be specifying these variables in the form of destination as well as in the form of source. And obviously the movement of operation will be taken place from the source to the destination. So mnemonics are nothing but the predefined keywords which are to be used for categorizing the operation or the group of instructions. Let us see one by one. Arithmetic group. So when I say there is a mnemonics followed by an operands, and these operands will be normally specified in terms of destination and the source. When I take the first instruction, add a comma rn. So here what is the mnemonics? The addition is add is an operation, and the keyword is add. This is represented as mnemonics, followed by a and rn operands, where rn is a source and a is a destination. So the content of rn will be added with accumulator, and the result will be stored in the accumulator. Fine. Similarly, a comma direct. The address is directly specified. So you will go to the direct address and take the data, and the data will be added along with the accumulator, and the result will be stored in the accumulator. And subsequently when we see the third instruction, a of at ri, it's an indirect addressing mode. We know that whenever the symbol followed by a register ri, it is specifically meant only for the registers r1 and r0. So the content, the indirect content of the register R1 and R0, the data will be analyzed or will be retrieved and then added along with an accumulator, and the result will be stored in the accumulator. These four instructions are normally not considering the inbuilt carry or performing the addition operation along with the carry. Whereas we do have the next group set of instructions to be performed with the help of carry. And whenever there is an immediate data to be accessed, we will have a symbol hash, followed by we will have a 8-bit data. The same will be applicable for subtraction instructions, and same will be applicable for increment, and the same set of instructions will be used for decrement with respect to the due mnemonics. For subtraction SUBB, for increment INC, for decrement it is DEC. And we do have a mul operation, division operations, and then we have a DAA instructions. All this will come under the category of arithmetic group of instructions. Logical group. So logical group is nothing but AND, OR, XOR and NOT. It performs bit by bit. So there also we have an RL, we have an indirect way of representation, then we have a direct representation, immediate data. The 4-set combination will be repeated for OR, XOR as well as clear, and then we have for complement. Data transfer instructions. What do you mean by transfer instructions? It can be used to transfer data between internal RAM and the SFR. So from one location, without executing the subsequent instruction, you can jump to some specific address location and start performing the operation. And that is to start transferring the data to that particular thing. So that is referred to as data transfer instructions. Data transfer instructions are normally represented by the indirect representation at RI or the DPTR, the data pointer. Data pointer is meant for 16-bit, along with the push and pop instructions and exchange operations. Boolean variable instructions. So when I say Boolean instruction, it will be either a 0 or 1. So whenever there is a single bit operations have been performed, they are represented as Boolean group of instructions. For example, set, clear, complement, ANL, logical of C, bit or XOR, everything, followed by jump on carry, jump on no carry to the corresponding bit. If that particular bit is equal to 1, the carry bit is equal to 1, we will be jumping to the specific location, else we will not be jump to the program control of the next instruction. These are all will not change the sequence, but at the same time which is used to have the flow control of the program execution. So that is what we call them it as program branching. So some of the instructions which I want to convey to you is nothing but the call as well as jump instructions. So whenever there is a call instruction is there, it will try to stop the current subsequent instruction execution and jump to a specific locations. And thereof we have a short jump as well as we have a long jump, and then we do have a term called absolute jump with respect to a specific or exact memory locations. Now we will detailedly know about all the instructions in detail. So add, what does this will do? It try to add between two, the source and the destination, and the result will be stored in the destination. So which of the flags are going to set here? One is carry, auxiliary carry, and overflow. Only these three flags will be get affected whenever whenever we try to do this instructions, and this will happen at the end of the execution of this instruction. Subtract. So when I say subtract, it tries to does the operation of the source and the destination, and the result will be stored in the destination. We do have an increment operation. It tries to increment the register content by the amount of 1. If it is a memory, it will increment the memory location by the amount of 1. So increment basically represents, it try to increment the set operand value by the amount of 1. Similarly, decrement also, it try to decrement the amount of set operand by the amount of 1. DPTR is meant for increment. DPTR is meant for a 16-bit register for. Similarly, we have a mul AB. So this instructions will be tried to perform multiplication operation between register A and B. The result of the lower order will be stored in accumulator, and the result of the higher order will go back and stored in the accumulator. Similarly, we have a division. We try to divide the content A by B. So So the result quotient will store in accumulator, the remainder will come back and store in the B register. Followed by we have a DAA, decimal adjust accumulator. If it is not the BCD, we try to adjust it and make it to the BCD by adding 6 either to the lower nibble or to the higher order nibble, so that the value will not reach the hexadecimal value. So ANL destination comma source, and we have an OR operation, and the syntax will be destination comma source byte, and we were aware of all those things. Rotate. So this is an 8-bit accumulator, used 1 bit to the left. So only 1 bit we are going to the left. So what does it mean? Left means moving to the left. So 1 bit moving towards the left, the last bit will be moved to a subsequent lower order location. Similarly, along with the carry, we are moving it. Rotate right along with the carry. Then we do have a swap instruction. Swap between the lower nibble and the higher nibble. If it is C3, it will be 3C. So we do have followed by we have a specific instructions called push and pop. So push instructions and pop instructions are the stack operations. Push is meant for storing data into the stack, and pop is used to retrieve the content from the stack. Exchange is between the source and the corresponding byte of information. Which we already come across. Return instructions. So whenever there's a call instruction is there, it will jump to that particular location. It start executing the instructions from the subprogram, and there is a return keyword should be there, RET. It will again return back to the main program and start executing from the next instructions. RETI is meant for the interrupt. We have absolute jump, long jump, short jump, which is of 16-bit. Sometimes we made in terms of 8-bit also for the sake of convenient analysis. And these are all with respect to logical group of operations. Thank you.